Hello! In this video I want to talk to you about the corticospinal system in just a little bit more detail. We've already discussed it in very general terms, but I wanted to show you a more detailed diagram and also talk about the idea of it splitting into two separate tracts. So we're going to look at the image on the right hand side first, and this is a summary of the entire corticospinal system, including the corticonuclear pathways going to the cranial nerve nuclei. So the first thing to remind ourselves of is that, of course, this system originates in the primary motor cortex, and we can see that the lower limb is represented medially, whilst the upper limb is represented laterally. We can see the pathway descending down through the corona radiata and then condensing further to form the internal capsule. And furthermore, what you can see is that the fibres for the upper limb and indeed the face are represented most anteriorly, whilst the fibres for the lower limb are represented most posteriorly within the capsule itself. As we descend further down, we then enter the brainstem through the cerebral peduncle. And what you can see here, interestingly, is that there are a number of fibres leaving this corticospinal system here and synapsing within the brainstem. And these are fibres of the corticonuclear pathway, which supply lower motor neurons present within the cranial nerve nuclei. The pathway then descends further through the ventral pons and then is seen to condense once more to form the pyramids. There is a pyramid on the left and a pyramid on the right. And you should remember that the pyramids contain fibres of the corticospinal system which have not yet decussated. So you can see these are all on this left-hand side. However, at the decussation of the pyramids, the corticospinal fibres cross the midline. And this is the point where I want to just emphasise that in fact not all of those corticospinal fibres do cross at this point. Around about 85% of the fibres cross over at the decussation of the pyramids to form the lateral corticospinal tract. So the lateral corticospinal tract in the lateral funiculus is made up of the majority of these crossed fibres. Whilst some of the fibres in the pyramids do not cross and descend down further through the cord ipsilaterally to form the ventral corticospinal tract. So about 15% of these fibres that have come from the cortex remain ipsilateral down through the cord, forming the ventral corticospinal tract. And only when they get to the level of the cord at which their lower motor neuron resides do they cross over and synapse on the lower motor neuron itself. So the corticospinal system is composed of two separate components: a much larger lateral corticospinal tract and a much smaller ventral corticospinal tract, which only decussates at the level of its lower motor neuron. Now functionally these two tracts are different. The lateral corticospinal tract is involved primarily in innervating muscles of the distal parts of the extremities. That is primarily two muscles of the arm or leg and the hand or foot. Okay? Whilst the muscles supplied by the ventral corticospinal tract tend to be those of the more proximal portions of the limbs. So the limb girdles, for example, tend to be supplied by the ventral corticospinal tract. So the lateral corticospinal tract, the majority of axons which cross at the decussation of the pyramids, supplies distal musculature, that is muscles involved in very fine movements, whilst the ventral corticospinal tract doesn't cross until the level of the lower motor neuron and tends to supply more proximal muscles. Now, I just want to mention one more thing, and that is the somatotopic organisation of the lateral corticospinal tract. Don't worry about the ventral corticospinal tract, but we do need to know about the somatotopy of the lateral corticospinal tract. So in the sensory system, we've already encountered somatotopy within these pathways, and we know, for example, within the dorsal column pathway, the more lower portions of the body are represented most medially, whilst the upper portions of the body are represented most laterally. And we also know, with respect to the spinothalamic system, ignore its separation into the different modalities, but we do know in the spinothalamic system that upper portions of the body are represented deepest or most medially, whilst lower portions of the body are represented superficially or most laterally. There is an organisation of the lateral corticospinal tract as well. And when you think about the way that this pathway organises itself and the fact that it has crossed over in the medulla, this kind of feeds into the logic of this somatotopic organisation. The upper limbs are represented most medially, then it goes trunk, and then lower limbs represented most laterally. And we can understand the logic of this by thinking that as we descend down through the cord, these axons most medially first get peeled off to supply the ventral horn of the upper limb. Descend further down, then we peel off these axons for the trunk in the thoracic cord. Descend further down from that, and then only these axons are left to supply lower motor neurons of the lower limbs. So that is just a more detailed overview of the corticospinal system and a consideration of the difference between the lateral and ventral corticospinal tracts, finishing with a discussion of the somatotopy of the lateral corticospinal tract itself. Thank you for listening.